All right. Cube roots of unity. Z cubed equals 1. Z minus 1. I mean to say Z cubed minus 1 equals 0. Factorizing, that's Z minus 1. Z squared plus Z plus 1 equals 0. This is Z equal to 1. And then this is Z equals minus B plus or minus the square root of B squared minus 4AC all over 2A. So omega is that guy. And then omega squared is the other imaginary root. And if you add the three roots together, you'll get 1 plus, and that's all over 2, and the I parts cancel. So it's 1 minus 2 over 2, which is equal to 0. And then next, you want to calculate 1 plus omega squared power 4. But that's equal to, now remember that this is true. So that means 1 plus omega squared, that's equal to minus omega power 4, which is equal to minus 1 power 4, omega power 4, which equals omega power 4, which equals omega cubed times omega. But that's equal to 1 since omega cubed is a cube root of 1. So 1 times omega, I mean to say, which is equal to omega, which is what it's supposed to be. Since omega cubed is a cube root of 1, or I should say, since omega is a cube root of 1, that means that omega cubed should be 1 then. Okay, so that takes care of part A. Then part B. This equation here, 4x power 4 minus 4x cubed plus 17x squared minus 16x plus 4 has 2 roots. Not 4 roots, has 2 roots. So the only way that could be possible is if it's a quadratic times a quadratic, but the same quadratic. So ax squared plus bx plus c squared, where b squared minus 4ac is negative because it has imaginary roots. It has 2 imaginary roots, and the other quadratic has to be the same quadratic, otherwise it would have 2 more roots. But this should equal ax squared plus c squared, since the roots are in the form plus or minus a I. Now that a is not the same as that a, so maybe just to prevent confusion, I'll call that alpha I. Why is this? Because if you think about the formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. If that's supposed to equal alpha I, that can only happen if this b part is 0. So that means that the b has to be 0. So you're just left with this now. We can see that a squared will have to equal 4 and c squared will also have to equal 4. So that means a will equal plus or minus 2 and c will equal plus or minus 2. But we want to make sure that b squared minus 4ac is negative. So b squared minus 4ac, that will equal 0 minus 4 times plus or minus 2 times plus or minus c, and that should be negative. That can only happen if all of these are minus, or if all of them, if we could have minus, minus, minus would do it, and minus plus plus would do it. So in other words, they have to be the same sign. So they can both be 2 or they can both be minus 2. And because we're squaring, it doesn't actually matter. So without loss of generality, we can say a equals c equals 2. So, in other words, that this equation here should equal 2x plus 2 squared, 2x squared plus 2 squared. So let's see what happens. Let's just test that out. That's 2. I can take that out. X squared plus 1 squared. So that's 4, which is good. And then that's x4 plus 2x squared plus 1. Now that doesn't match up. So that's because then there's one more possibility. So it could be quadratic, and then it could have... I'm actually surprised that that did not work. Is it possible that it actually has more than 2 roots and they're just telling me it has 2 roots in the form of plus or minus alpha I? That'd be really confusing. Do you know, they never actually explicitly says has only 2 roots. So that's kind of a bummer. It means that this question has gone a lot more complicated. I thought I was nearly finished. So it could be the case that you have it like this. Squared minus 16x plus 4. That is going to be a quadratic with no b in it. So that's ax squared plus no b plus c. And then something else, another quadratic, which we'll call ax squared plus bx plus c. So if this guy is responsible for that, then what we can do is we can say that this here must be, now I'm going to call that alpha so it doesn't get confusing. This must be something like x squared plus alpha squared, because this will have roots of plus or minus alpha I. But then if I do that, it forces this one here to be a 4. But then I have to think about the other 2 coefficients. So I have to figure out what the alpha is and then to fully solve it. Have I got enough information? I probably do, but then I have to multiply this out. So let's do it. So that's 4x4 plus bx cubed plus cx squared plus 4 alpha squared x squared plus b alpha squared x plus alpha squared c. So that's 4x4 plus b, is there no other cubes? 4, 3, 2. Okay, it's just, okay. Plus bx cubed plus c plus 4 alpha squared x squared plus b alpha squared x plus alpha squared c. So b will equal minus 4. And then by just comparing, so like this coefficient here has to match this one. And then if we look at this one here with this one, I think we can get the alpha. So that implies that minus 4 alpha squared equals minus 16, which implies that alpha has to be plus or minus 2. Okay. But then if we look at the last one here, so 4 has to equal alpha squared times c. So that implies c has to equal 1. And then lastly, the b. And I have the b. And I have the c. Oh, I have everything. So this equation now becomes x squared plus alpha squared, so plus 4, times 4x squared minus 4x plus 1. So this one has roots of plus or minus 2i. So it doesn't matter, I guess you could just say, oh yeah, plus or minus 2i, so therefore, yeah, the alpha is 2. So actually I didn't really need to write the minus there. So the alpha is 2. Yeah, so that's actually what I just wrote a moment ago. And then we just have to finish it by getting the other factors. Does this have factors? X squared plus 4 times 2x. And then 2x maybe. Has to be 1 and 1 here. 2x. 2x by 2x, 4x. Yeah, it's 2x minus 1 squared, isn't it? That's 4x squared minus 4x plus 1. Yeah, there we go. So that's the value of the alpha there. And the roots are plus or minus 2i. And then 1 over 2. Yeah, right. That's kind of tricky, that question. But we're finished now, so that's good.